out to be 0.43559.8, let's say. And then I have over cosine squared. Now what could I do? Well, I could argue that 1 over cosine squared is secant squared. Okay? Then I could write that as 1 plus tan squared. So then I could rewrite this as then I could distribute this in, take this times that, it's going to be itself, take it and add it to that. So add it to 0.42, I have 0.855559 0.855598. Simply just add that, add it to this. Then I have on this side 1.65 tangent theta tan squared. Now, where did that get us? The goal of this whole thing was so that I have something tangent squared, then I can say let A equal tangent theta. Then that's a certain variable. Then this will become A squared. Now I could take this over to the left side and I have 0.43559.8 A squared. I could take this to the left side, minus 1.65A plus 0.855598 equals 0. Now I can actually solve for A with the quadratic equation, or I could just simply put it into my TI and have the calculator do this for me. Polynomial. So I could put here 0.435598, which was this thing here, 0.435598. That's the coefficient of the A squared. Then I can have negative 1.65. That's the coefficient of the second variable. And then I can have 0.85598. Solve. It tells me A is equal to 0.62 or 3.167858. Now what does that mean? There's two answers here. Well, remember, A is tangent theta. So there's two angles that I can aim at where it could potentially go and be a basket. Now, this one gives me tan inverse of 0.62. In order to figure out what angle it is, I'm going to have to take the tangent inverse of 0.62. .8 degrees. So with 31.8 degrees, I should make a basket. But that's a pretty sharp basket. So it's you don't have any room for error. It's going to go like this. You're going to go like this. And it's going to go like that. And just make it like that. Let's see. The other one gives me a much steeper angle. Very, very high. Tangent inverse of 3.167858. .72 degrees. So let's try it actually here. 72 degrees and 31.8. So rounding 31.8, let's just say about 32 degrees. So you could see here, I could put it at roughly 32. Okay, and then I'm going to have the bowl. This is 32 degrees now. And hopefully we make the shot here. Okay, no room for error. Now remember, when we're applying the equations of projectile motion, we are ignoring what? Air friction, right? We're ignoring the effects of air friction. So the ball is really not going to go as far as the equations predict. So when I did 32, I can keep doing it. It's not going that far. It's going a little lower than what it needs to go. So how would I adjust for air friction? Probably make the angle a little higher, right? Maybe 34, 35. And then I would make it. So let's just say I adjusted a little bit more. I now have it at 35. Basket. Okay, so that means with adjusting with air friction, I went up a little bit and it went in. Now let's try the other angle. The other angle was 72. Now I am going to do it without any adjustments. 72, this is a pretty high angle here. Okay. A little short again. It went like this and it hit the front edge. So again, air friction. Okay, let's try again. A little short again. This time I'm going to have to make the angle a little smaller than that, right? So that it won't go up in the air that long. You'll have a chance to actually making it. So let's go down to, let's say, 69 maybe. 3 degrees. So I have it about 69. Perfect basket. So roughly about a 2-3 degree adjustment makes it go in. So if you're a basketball player or anything else, this is all the stuff that goes into any kind of ballistic projectile motion situation. Thank you.